Hello everyone, welcome to this video. In this video, we shall be looking at another question which has been taken from GATE 2001 paper. This is a 2-mark question. So in this question, they are saying that if we have z and positive, so this is the z of the group of integers under the operation of addition, right? We have this thing, then what would be the number of automorphisms of this group? So if you remember what are automorphisms, so suppose this group Z is given to us, so that means all the integers are there with us, right? And moreover, the operation here is, the group operation here is addition, right? So that means if you remember, we can define some mapping phi, right, from the same group to the same group such that this mapping is an isomorphism. So that means this is 1 1, this is onto, and this is homomorphism, correct, which preserves the order. So we have, if we have all the three things with us, this is an isomorphism, and moreover it is going from the same group to the same group. So in our case it is going from Z to Z, so that means it would be an automorphism. So we need to define how many such mappings would be there in this case. So what will be the number of all the isomorphisms which are based on this particular group, right? This is the question. So here we are saying the number of automorphisms are 2 in number. So that means B is the correct option. Now let's see why this happens. Which all automorphisms are there? The first automorphism is the identity automorphism. Here it takes the number n to the number n. So that means it is not doing anything. So it is just taking the number 0 to the number 0, 1 to the number 1, 2 to 2, 3 to 3, minus 1 to minus 1, minus 2 to minus 2, minus 3 to minus 3, and so on for all the other elements, right? So that means you are again getting back the set of integers. So this is an automorphism, right? And you can clearly see there we have a 1-to-1 correspondence here in this case, right? So in this case, what we are, how we are writing our integers, we are writing our integers when we are mapping it to left to right. So we are starting from minus infinity and we are going up to plus infinity. What if we reverse the order? What if we start from infinity and we move to minus infinity? So that is done by multiplying all the integers by minus 1. So this is our next mapping, which is moving n to minus n. So now we are, instead of moving from left to right, we are moving from right to left in this particular case, correct? So these are the two automorphisms. In fact, we are saying these are the only two automorphisms of this group of integers, right? And so that whatever is the automorphism group which is constructed by taking the members as these two automorphisms, the member of this group are these two automorphisms, right? So this group would be isomorphic to the group automorphism group of Z would be isomorphic to the cyclic group which is having order 2, right? Which is having order 2. So this is what we are saying here. Now why this is so? It is because because we know the set of integers, the group of integers, that is a cyclic group, and under addition here the generator is minus 1. Correct, because you can add minus 1 infinite times to get all the elements of this group Z, right? So this automorphism, this is completely determined by its value at 1. Why? Because by adding 1 several times you may have all the elements of this group, right? Now suppose we define another automorphism, say we define n going to 5n, right? So that means 1 is going to 5, and so all the elements 1 plus 1 is going to 5 plus 5, so it would be 10. 1 plus 1 plus 1 is going to 5 plus 5 plus 5, which would be 15, and so on. So the outputs in this case would all be multiples of 5. So when we are applying this automorphism, the output that we are getting is just the multiples of 5, and so all the numbers which are not multiple of 5 are missing as outputs here in this case. So therefore this cannot be our automorphism, because this is unable to define a bijective map to all the elements of the group of integers, right? So therefore 1 can only be sent to either the number positive 1 or the number negative 1. in order for this to work, and hence we only have two automorphisms with us. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.